So this is an array, and the way we declare an array is integer A5. Okay. So A is an array of 5 elements, 5 integers, right? So if it is Java, then we will declare it like this: integer A is equal to new integer 5. All right. But for the time being, let's focus on C language only. This is an array of 5 integers. Okay.
Yes, sir.
If it is array of 5 integers, then all the 5 elements will be contiguous. So contiguous means that this is A0, then this is A1, this is A2, this is A3, and this is A4. So if I say A2 is equal to 4, then 4 will go here. The benefit of using an array is that array is a random access memory. Random access means that it will take the same time to access any element. The time to access the first element, second element, third element, fourth element, fifth element is same. It is constant. How can the time be constant? So let's say integers are allocated 2 byte memory. So these 2 bytes are allocated to A0. These 2 bytes are allocated to A1. These 2 bytes are allocated to A2, A3, and A4. Right? So let's say this is address 10, this is 11, this is 12, this is 13, this is 14, this is 15, this is 16, this is 17, this is 18, this is 19, and this is 20. Okay. So this entire memory from here till here, this entire memory is A.
Yes, sir.
So if I print A, then 10 will get printed because 10 is the address of array. And in most of the cases, the data type of A is integer pointer. So what it means is that the name of the array name act as a pointer to first element of the array. Pointer to first element of the array, right? Because the first element is integer, so that's why it will act as an integer pointer. Now, if I say A plus 1, what do you think will be A plus 1?
A plus 1. It will be. I actually.
Okay, no
I
problem.
guess.
If A is 10, then A plus 1 can be either 11 or 12.
Yes, sir.
Let's say this is a road, and on one side of the road you have 100 square yard houses, right? So all of these houses are 100 square yard houses. On the other side of the road, the houses are bigger and you have 200 square yard houses. Okay.
Yes, sir.
If a person is standing here and you ask this person to go to the next house, so how much will this person move? This person will move 100 yards.
Yes, sir.
But if a person is
100.
here and if you ask this person go to the next house, then this person will move 200 yards, right?
Yes, sir.
Okay. To both of these people, our instruction is the same. What is our instruction? Our instruction is go to next house, right? So when we say go to next house, it means that we are saying move one step forward. So when we say increase yourself by 1, then the green one increased itself by 100 square yard and the blue one increased itself by 200 square yards.
Yes, sir.
Okay. The same thing is true for pointers. If it is an integer pointer, if an integer pointer is pointing here, and if you say if you do a plus 1 to that integer pointer, then it will move by the size of integer, right? So can I say that A plus 1 will be equal to 12? If the size of integer is 4 bytes, then A plus 1 will be 14.
Yeah.
And if size of integer is, let's say, hypothetically speaking, if size of integer is 8 bytes, then A plus 1 will be 18.
18. Yeah.
Right? And if size of integer is only 1 byte, then A plus 1 will be only 11, right?
Yes, sir.
When I say A2, okay, the compiler translated to value at A plus 2. So A plus 2 means this memory,
Yes, sir.
right? And value at this memory. All right.
Okay.
So if I say A2 or if I say A3, in this case, the compiler will do value at A plus 3. So whether the compiler is doing value at A plus 2 or it is doing value at A plus 3, the time taken in both the cases will be same. Okay. So this is the reason we say that the time taken to access any memory in an array is constant, is same. Okay. So this is the advantage of using an array, that you can access any element of the array, and irrespective of which element you are accessing, the time taken to access the element is going to be the same. And that is why this is random access memory. However, the disadvantage of using an array is that the size of the array is fixed. Okay, you
Yeah.
can't increase the size of the array, right? Why can't you increase the size of the array, by the way? Let's say someone asks you that, why is it that we can't increase the size of the array? So
Yes, sir.
you can't increase the size of the array because let's say I have defined the array of size 5. The
Yeah.
5 elements of the array are allocated here.
Yes, sir.
After that, let's say I declare another variable p. So variable p will be allocated memory here. After that, I allocate another variable q. So that variable q will be allocated memory here. Now, if I want to increase the size of this array and instead of 5 elements, I want to store 6 elements, I do not have room to increase the memory, right? Because the array has to be contiguous.
Yes, sir.
Okay. So array has to be contiguous. Array cannot, you can't have a scattered array that, half of the array is lying here and half of the array is somewhere else. Does it make sense or not?
Yes, sir.
Therefore, in C, C++, Java, in all of these cases, the array, when we declare an array, the size of the array, once it is allocated memory, the size of the array become fixed.
Yeah. Okay, sir.
Okay, but you can counter argue. You can say that in Python we have list, in C++ we have vector, in Java we have array list. Java also has vector. So all of these are arrays, but their size is dynamic. So all of these are dynamic arrays. So how is
Yeah.
it that Python can have a dynamic array, C++ can have a dynamic array, but the dynamic array will be vector, but normal arrays are fixed in size? You understand the question?
Yeah.
Okay. So it means that they must be using some other design to allocate memory to the dynamic array, right?
Yeah, sir.
Okay. So this is your homework, that just read about dynamic arrays. That
Okay.
how can you create, let's say you are using your own programming language, right? So in your
Yeah.
own programming language, how can you create dynamic arrays? Or let's say you want to create dynamic arrays in C language. So how can you design dynamic arrays in C language? So you can give a brief presentation on dynamic arrays, right? And if you find anything difficult, then we can discuss it, right?
Okay.
Okay, all right. Now comes linked list. So in linked list, uh, we do not have contiguous memory allocation. What happens is that the first element has, let's say the first element is 5. First element to have the data means the value, and first element stores the address of the
Yes, sir.
second element. So second element has its
Yeah.
own value. Let's say the second element value is 7. So we have an array of 5 elements. Okay, this is 5, 7, 9, 3, 2. If we have a linked list of 5 elements, then what we do is we store 5, and then 5 will store the address of 7. Then 7 will store the address of the next element whose value is 9, and 9 will store the address of next element whose value is 3, and 3 will store the address of the next element whose value is 2, because 2 is the last element, so next of 2 will be null. Does it make sense?
Yes, sir.
Instead of one element, now we have a structure, right? So this is
Yeah.
structure. You must have read structures in C language, right?
Yes, sir.
Okay, so this structure node, and node has one integer data and node pointer next. So we have a structure. This structure has the data field. This is the data field, and this is the next field. So next is a pointer to the next element. Now let's say we have 3 variables of type node. Okay, so we have A, B, and we have C. If we declare these 3 variables, it means that there will be 3 nodes. The
Yeah.
first variable name is A, right? The second variable name is B, the third variable name is C. Let's say the address of A is 100, the address of B is 200, and the address of C is 300.
Okay.
Okay, then we say
Okay.
that A dot data is equal to 5. It means that 5 comes here,
Yes, sir.
right? Then we say that B dot data is equal to 10. It means that 10 is here, and C dot data is equal to 15. 15, it means that 15 is here. Does it make sense?
Yeah. Yes, sir.
Okay. Now a dot next. A dot next can hold an address of node. Can I
It.
say a dot next is equal to address of B? Will it be
Mm,
valid or not?
yeah, it can be valid, sir.
Right? Because address of B is address of node and
Yeah.
next is a node pointer. It means that it can store node address,
Yes, sir.
right? So we have 200 here. Instead of putting 200 here, I am just, or maybe, let me just write 200, right? Otherwise, we can just show it as a pointer.
Okay.
Then next is B dot next is equal to address of C. It means that we have a 300 here, right? Or we can
Yes, sir.
show it as a pointer. And then C dot next is equal to null. So pointer can be null. It means that it is not pointing to anything. All right.
Yes, sir.
All right. Now you tell me what will be the output. So if I print a dot data, then what will be the output?
It will be 200.
This is a, right? Okay.
Yes, sir.
So a has a data field and a next field, right?
Yeah.
So in the data field, we have stored 5
Five.
and in the next field, we have stored the address of B,
Yeah.
right? So if I say a dot data, can I say that it will be 5?
Yeah, it will be 5. Yeah.
Okay. If I say print a dot next, then what will get printed?
Then we get 200, the address of
200.
B.
Great. If I say address of A, then what will get printed?
We get 100, sir.
Perfect, right? If I say address of B, then what will get printed?
Address of B, it will be 200, sir.
200. Perfect. If I say B dot data, then
Then it will be 10.
perfect. If I say B dot next,
It will be 300.
300. If I say C dot data,
It will be 15, sir.
15. If I say address of C,
Address of C is 300. Yeah.
300. Perfect, right? What if I say A? Then it will print nothing because A doesn't mean anything. A is the entire structure, right? If I say value at A dot next, then what will get printed?
The address of it will be 10, sir.
What is A dot next? A dot next is 200.
200. Yeah.
So value at 200 is 10 or value at 200 is the entire structure,
Yeah, it will be the entire structure.
right? So
Yeah.
it is as if, I say print B. So print B does not make sense, right?
Yes, sir.
All right. But if I say value at A dot next dot data, then what will get printed?
Then we get 10, sir.
Perfect. Then we get 10. All right.
Yeah.
So, there is a shortcut for this, and we can say a dot next arrow data, right? So arrow
Yeah.
is a shortcut of saying star value at n dot. Okay.
Okay.
Now let's say we have a node pointer. So we do not have a node, we have a node pointer. Okay.
Yeah.
So we have a node pointer and the node pointer is h. So if h is a node pointer, then it is only a pointer. It can only hold one address and it can hold the address of node only. Let's say I say that node pointer h is equal to address of a. Then here we will have 100.
Yes,
Okay.
sir.
What it means is that h is holding the address of a.
Yes, sir.
All right. H is holding the address of a. Okay. Now what I say is that print means sysout system.out.println value at h dot data. So what will get printed? Okay, I'm mixing couple of things. I'm mixing C++ and Java, right? So let me say C out. Okay. So if I say this, then what will get printed?
It will be 5.
It will be 5, right? So value at h is the entire A. What is the shorter way of writing this? H arrow data,
Yes, sir.
right? So this is just a shorter way of writing this, right? H arrow data. Okay.
Yeah.
So after printing h arrow data, I say that h is equal to h arrow next. What will happen now? So can I say that H arrow next is 200? So
Yes, sir.
H will hold. So here 200 will come here. What it means is that H will start pointing to B, and this link is broken.
Yes, sir.
Okay. And if I again do the same thing, then what will happen?
Yeah, it goes to C. Yeah, it
Yeah.
like continues till the last value.
Okay. So first it will print 5, then H will start pointing to B, then it will print 10, then H will start pointing to C, then it will print 15, and then H becomes equal to null. And when H becomes equal to null, then the loop will stop.
Yeah, yes, sir.
All right. What it means is that we are not using the name of these nodes,
Yeah,
right? Okay. Can I say that till now, this entire thing is in the stack area of the memory?
it is in the stack. Yeah, stack area.
It is in the stack area, right? But if I do not use the name of these nodes, then I can put the nodes in the heap area and only the head pointer will remain in the stack area. So what will happen is that I have a node in the heap area. Okay. So this is heap area and this is stack area. Okay. So I have a node in the heap area and the value of the node is 5. And let's say the address of the node is 100. And this node contains the address of another node. The value of the data of this node is 10, and this node contains the address of another node. The data of that node is, let's say, 15, and this node contains the address of another node. The data of that node is 20, and let's say the next of this node is null. Okay. And we have a
Yes,
pointer and we have a node pointer variable in the stack area, and this pointer variable is holding the address of the very first node of the stack, a very first node of the list. Okay, so this is the typical arrangement of linked list in all the programming language, irrespective of which programming language you are using, whether you are using C language or C++ or Java or Python. In all the programming language, what happens is that this linked list will be created in the heap area and in the
okay.
stack area, which means that uh, in the stack frame of the function, we will have a pointer that is pointing to only the first node of the list. Does it make sense?
Yes, sir.
Okay. Now, all the manipulations that we have to do through this head pointer only, because we do not have the address of the second node, we do not have the address of the third node, fourth node, fifth node. We don't have the address of any other node. We only have the address of the very first node of the list. Okay. So if you want to print the second node, then we have to go to the second node via the first node and then print the second node. If I want to print the last node, then we have to hop, right? So from first node we will go to the second node, from second we'll go to the third, from third we'll go to the fourth, and so on. We'll go to the last node by hopping each and every node, and when we reach the last node, then we will print the data of the last node. Does it make sense?
Yes, sir.
How much time will it take to print the last node?
Mm,
To reach the last node, you will have to iterate
it
this
will
while
have
loop n times if
n
there are
times.
n nodes in the list, right?
Yes, sir.
Okay, so therefore, if you want to print kth node of the list, then you will have to run the iteration, you will have to run this while loop k times. Okay,
Yeah.
and this is where the disadvantage of linked list comes, because linked list is not random access like an array. Array was random access, right? Whereas
Yeah.
linked list is not random access. So
Yeah.
the time taken to access an element in a linked list depends on the distance of depends on the distance of that element from the head of the list, right?
Yes, sir.
Okay. Second challenge in a linked list is that we should never lose the pointer to the first node. If somehow we lose the pointer to the first node, then the entire linked list will be lost, because the nodes of a linked list does not have a name, right? Because the nodes of the linked list are getting created in the heap. They do not have a name. And therefore, we should make sure that we always preserve the pointer to the first node of the list. Does it make sense?
Yes, sir.
All right. So,
Okay.
these are the challenges of dealing with a linked list. And if we lose the pointer to the first element, then in case of C++, it will become a memory leak. In case of Java and Python, it may not be a memory leak, but we will have a distorted list. Okay.
Okay.
All right. So this was a very small introduction to linked list. From tomorrow, we'll start doing questions of linked list.